The entire British Isles are sitting on ancient coral. All that limestone, the white cliffs of Dover, the bedrock beneath London, that's all carbon that coral pulled out of the atmosphere and locked away for tens of millions of years. When coral builds its calcium carbonate skeleton, it takes carbon out of circulation and keeps it out for geological time. Coral animals showed up in the fossil record around 500 million years ago, making them one of the earliest animals to appear on Earth. They're in the Cnidarian phylum, the same family as jellyfish, and they barely changed their basic design in all that time. The modern reef-building ones, called scleractinians, appeared around 240 million years ago and started building the massive structures we see today. Each coral polyp is covered with stinging cells that fire microscopic harpoons at prey that floats by. If you scaled that firing mechanism up to human size, those harpoons would be traveling at Mach 580. Jets fly around at Mach 5. The acceleration is absolutely insane, but it only happens over this tiny microscopic distance, so you have to imagine it enlarged to human size for it to mean anything. It's like a drag racer with a 1-inch track. Incredible acceleration, but not much distance to work with. Coral has this partnership with an algae called zooxanthellae. That's a tongue twister, which literally means little yellow animal. Because when it was named, scientists didn't know what it was. They just knew it was yellow. The algae lives inside the coral cell and provides 90% of the coral's nutrients, which is wild because coral are carnivorous hunters. That partnership has been going on for at least 210 million years. The fastest growing branching coral adds about 4 inches per year. The massive boulder corals grow about 1/10 of that, roughly 1 banana slice worth of growth annually. But these colonies can live for thousands of years. Some brain coral specimens in the Caribbean are over 900 years old, meaning they were already growing when Columbus showed up. Coral covers about 134,000 square miles of the planet, and that algae partnership is critical to their survival. When water temperatures change beyond certain thresholds, coral expels the algae living in its cells, which makes them turn white, bleached looking. Without the algae providing 90% of their food, the coral can starve to death. We've only been tracking these bleaching events globally since 1998, and the data is inconsistent. It's not happening at regular intervals. There are plants like bamboo that bloom and die simultaneously all over the world on some internal clock that nobody understands, regardless of where they are or what climate they're in. Is coral doing something similar to that? We don't know. We just started paying attention. When there's ice age conditions and the Earth is covered with snow and ice, sea levels drop and there's more shallow water shelf for coral to grow on. The question is whether coral peaks during glaciation or whether that's when they're at their lowest point. There's debate over that, but understanding these cycles matters more than you think. Coral plays a huge role in the planetary carbon cycle that took millions of years to calibrate. And if we're going to colonize other planets, like they want to do, for instance, the Moon, Mars, whatever, we better figure out how to make biodomes stay efficient and effective. You need to know how these systems work together before you try building them from scratch somewhere else.